All right, we're looking at 3.1.5, and finally we get one with a non-zero a value, so we have an x squared term. All right, so what we do first is replace x with alpha plus y, and that completely transforms the equation to a cubic with an x to a cubic with a y. We're gonna have to undo that later, but we'll talk about that in a bit. So once you choose, every time you choose alpha plus y, all right? But once you go through all that and then you look for all the y terms like y cubed, y squared, y, and y to the 0 power term, we choose an alpha value. I'm looking right here, an alpha value that will cancel out my y term. So that'll be -1. And then we simplify further into this here. So we get y cubed plus 6y minus 2. So that puts us in something of this form now. And we can go ahead and solve as if it was the 3.1.1 and 3.1.3. So now I'll just repeat those steps, except the a value this time will be non-zero. So go ahead, I'm just looking right here. It's just the pre-calculus moves to get to 4 and -2. Either one of these will work. I choose +4. Then just use proposition 2.7, page 20, and we took a bit of a shortcut there. We just get the third root of 4 omega, third root of 4 omega squared, and third root of 4. If you're not familiar with that, just go ahead and watch 3.1.1 and 3.1.3, and I did it very slow that time. This time I did it just a bit quicker. So if you are having any trouble with this step here, just watch the previous videos and you'll be good. All right, so now what we're gonna do is go to page 47, and you will see the equation yi equals zi minus p over 3zi, and xi equals yi minus a over 3. Now just combine these two equations and we get this equation here. And what's different this time is this a value is non-zero. This a value is 3. All right, because the a is near the a is the x squared coefficient. So just go ahead and plug these in. And if you're having any trouble, for example, on this step here where we transfer this omega to an omega squared, just watch the previous videos and there's an explanation for that. And we get our 3 solutions. So once you get the 3 solutions, we're good to go and we got the answer. All right.